Blocks A and B of masses MA and MB respectively are connected by a string that passes over a pulley. Block A is suspended from the string and block B is on a frictionless, so we don't have any friction on the surface as modeled below, which expression represents the magnitude of the acceleration of the block. So because we don't have any friction, there isn't any other force to oppose the motion that you'd have in the leftward direction because of the weight of this block, which is mg. So m is the weight, a mass of m of A. So this one. So when the force pulls the string, we have a tension T here pulling this side, and from A's perspective, obviously a tension X in the opposite direction. So from B's perspective, we label tension away from B, and from A's perspective, we label tension away from A. So this there isn't any force, any friction force to resist this motion. So when we find the magnitude of the acceleration of block A, we have to first find the acceleration for both of this block. Also for block B, we can equate F equals to ma. Resultant force in this case is only provided by tension equals mass of B times A. Because this thing is connected, because this is both of these objects are connected by a same string. This is a connected system, and within the system we have the same acceleration. That's why we can use the same symbol A. So for A, F equals ma. The resultant force this time is T, is because acceleration would be in this direction. So this must be greater. So we write F of G, M of G minus T. This is the resultant force equals mass, which is M of A times the same acceleration. And because we want to find the acceleration of the block, we equate T. So mg minus ma of A equals T. And we equate this to T. So we have mg minus m of A equals m of B times A. So they have asked us to find acceleration of block A. So we make A the subject, but before we do so, okay, so this would be m of A actually. Okay, so we make ma acceleration of block A. So we have to make A the subject. So A times mb plus equals mag. So this is as it is here. We add plus ma times a to cancel this out with and come with the term mb times a. So we can take a common from here, and we have m of a g upon. So these two will be cancelled out, and we have m of a and not b. So d is our answer, and it would be mb plus ma. So yeah, d would be our answer. Okay. A student has a spring scale and a balance scale as modeled below. Which approaches could the student use to measure or calculate the inertial mass of a block? Okay. So place the block on a horizontal surface that is approximately frictionless. Use use a spring scale to pull the block across the surface with constant force. Measure the block's resisting acceleration. Yes, because we're not trying to find the gravitational mass. You would the approach F equals to ma does the job, so A is our answer. But hang the block from the upscale. So when we do so, we won't be able to find the inertial mass. We get the gravitational mass. Hang the block from the spring scale. We record the force reading. No, this is not what we get. While the block hangs at rest, place the block on a pan of the balance scale. Gradually add masses until the two sides level. Again, these two would measure the gravitational mass, but inertial masses can be only measured by option A. There we go. The magnitude of gravitational field at Earth's surface, gravitational field at a surface. So this is the Earth. At the surface, we have g of e. The planet X has 2 times the radius. So if we have r here, you have a planet X. That is, let's say, not to scale, of course, 2 times the radius and 4 times the mass. So this is m. This is 4m, the mass of the Earth. 2 times the radius, 4 times the mass. What is the magnitude of the gravitational field at the surface of planet X in terms of GE? So, for the gravitational field for the Earth, what do we have? We have G equals to Gm over r squared. But for this one, we have G into 4m over r squared, which is 2r squared. So 4 times gm over 2 squared is 4, r squared. This gets cancelled out. What do we have? The same thing. So which means what? They're same. There we go.